Welcome back to Botanical Bliss, fellow garden enthusiasts. Today we're uncovering a truth that might surprise even seasoned gardeners. Many products marketed as beneficial for your garden might actually be damaging your soil's long-term health. As someone who's spent years nurturing gardens and studying soil ecosystems, I've seen firsthand how certain common ingredients can disrupt the delicate balance that makes gardens truly thrive. Think about it. Your soil isn't just dirt. It's a complex living ecosystem that forms the foundation of everything you grow. When we introduce products that harm this ecosystem, we often find ourselves trapped in a cycle of dependency on more and more amendments, while our soil's natural vitality continues to decline. Let's explore these hidden soil destroyers together and discover healthier alternatives that align with nature rather than working against it. The living soil web. What we're actually protecting. Healthy soil contains billions of microorganisms in every handful. Bacteria, fungi, protozoa, nematodes, and larger creatures like earthworms and arthropods. This underground community breaks down organic matter, creates soil structure, suppresses pathogens, and makes nutrients available to plants. When this soil food web is intact, plants develop stronger natural immunities and produce more nutritious harvests. The most successful gardens aren't those with the most inputs but those with the most vibrant soil ecosystems. Now, let's identify the common products that disrupt this vital web of life. Synthetic chemical fertilizers, the addiction cycle. Those bright blue crystals promising bigger blooms and faster growth deliver immediate results, but at what cost? Synthetic fertilizers, particularly high nitrogen options, essentially force-feed plants while bypassing the soil food web entirely. This creates several profound problems over time. First, these concentrated salts can kill beneficial soil fungi, particularly mycorrhizae, the underground networks that extend plant root systems and dramatically improve nutrient uptake. Research from the University of Minnesota demonstrates that synthetic fertilizer applications reduce mycorrhizal colonization by 40 to 60% within a single growing season. Second, synthetic fertilizers disrupt the natural nitrogen cycle. When plants receive ready-made nitrogen, the soil bacteria responsible for nitrogen fixation essentially become unemployed and diminish in numbers. Over time, your soil becomes increasingly dependent on these external inputs as its natural fertility mechanisms atrophy. Most concerning is how synthetic fertilizers acidify soil by leaving behind hydrogen ions as plants uptake nutrients. This gradual acidification dissolves clay particles, damages soil structure, and makes it increasingly difficult for earthworms and beneficial arthropods to thrive. Instead, transition to organic, slow-release fertility sources, compost, well-aged manures, alfalfa meal, and cover crops. These feed soil life first, which then makes nutrients available to plants in balanced forms. The transition period takes patience, typically 1 to 2 growing seasons, but results in more resilient plants with fewer pest and disease issues. In my own garden, switching to organic fertility sources reduced disease problems by nearly 70% within 3 years. Sterilized growing media, the biological vacuum. Many potting soils and seed-starting mixes proudly advertise being sterile or pasteurized. While this prevents certain soil-borne diseases in the short term, sterile media create a biological vacuum that ultimately leads to weaker plants. Plants have evolved over millions of years in partnership with soil microorganisms. Their roots actively release sugars, known as exudates, to feed specific beneficial microbes in exchange for nutrients and protection. When grown in sterile media, plants waste energy producing these exudates with no microbial partners to respond. This makes them more vulnerable to opportunistic pathogens and reduces their nutrient absorption efficiency. Research published in the Journal of Applied Ecology demonstrates that plants grown in biologically active media develop more extensive root systems and significantly higher stress tolerance compared to those in sterile media. Dr. Elaine Ingham's work at Soil Food Web Inc. further shows that plants in living soil require 30 to 50% less water and fertilizer to achieve the same growth. Look instead for compost-based growing media containing beneficial biology, or inoculate conventional potting mixes with compost tea or worm castings. Even a small amount, around 5 to 10% of quality finished compost, can introduce vital microorganisms that transform sterile media into living soil. Persistent herbicides, the long-term contamination. Perhaps the most insidious soil killers are herbicides containing compounds like clopyralid, picloram, and aminopyralid. These chemicals designed to kill broadleaf plants can persist through composting processes and remain active in soil for 2 to 5 years. Many gardeners unknowingly introduce these into their gardens through contaminated compost, manure, straw, or hay. These herbicides are particularly damaging because they don't just kill weeds, they disrupt the hormone systems of all plants, including soil fungi. Research from Washington State University demonstrates that gardens contaminated with these herbicides show up to 85% reduction in fungal diversity, particularly affecting the mycorrhizal species critical for soil structure and plant immunity. The signs of contamination include twisted, curled growth on sensitive plants like tomatoes, beans, peas, and potatoes. Unfortunately, once these chemicals enter your soil, remediation takes years of intensive carbon additions and microbial treatments. Protection requires vigilance. Know your compost sources, ask specific questions about herbicide use when purchasing manure or straw, and consider conducting simple bioassay tests, like growing bean seedlings in a sample, before incorporating new organic materials into your garden. I maintain a relationship with local organic farmers specifically to ensure clean inputs for my garden. Fungicides. Friendly fire on beneficial fungi. When powdery mildew appears on squash leaves or black spot invades roses, many gardeners reach for fungicides without realizing the collateral damage they cause. Most fungicides cannot distinguish between harmful and beneficial fungi, often killing the very organisms that would naturally help plants resist disease. Mycorrhizal fungi, which colonize plant roots and dramatically extend their reach into soil, are particularly vulnerable to fungicides. These fungi can increase a plant's root surface area by up to 1,000 times and play crucial roles in disease suppression. Yet research from Cornell University shows that common garden fungicides can reduce mycorrhizal colonization by 40 to 90%, with some impacts persisting for multiple growing seasons. Even copper-based fungicides, often marketed as organic, accumulate in soil over time and can harm earthworms and beneficial microarthropods at concentrations commonly found in regularly treated gardens. Instead of reactive fungicide applications, focus on prevention through proper spacing, resistant varieties, and building soil health. When intervention is necessary, target specific problems with minimal impact alternatives like diluted milk sprays for powdery mildew or compost tea as a preventative treatment. My own garden has been fungicide-free for 5 years, with disease pressure decreasing each season as soil health improves. Chemical pesticides, disrupting the underground food chain. Insecticides applied to control visible pests often have profound effects on soil-dwelling organisms. Neonicotinoids and organophosphates in particular can persist in soil and harm beneficial arthropods like springtails and mites that break down organic matter and control harmful nematode populations. Even more concerning is recent research from the Netherlands showing that many insecticides alter soil bacterial communities, particularly reducing the populations responsible for nitrogen cycling. Gardens regularly treated with broad-spectrum insecticides typically show 30 to 50% less biological activity in soil testing, creating a cascade of negative effects on nutrient availability and plant health. The most problematic aspect is how these chemicals create dependency. By killing beneficial predators alongside pests, they ensure pest populations rebound more quickly while their natural controls remain diminished. This creates an intensifying cycle of chemical dependence. Build natural pest resistance instead by focusing on soil health, plant diversity, and habitat for beneficial insects. Targeted organic controls like insecticidal soaps, neem oil, or diatomaceous earth can address specific problems without the same collateral damage. In my demonstration garden, converting from conventional pest control to an integrated biological approach reduced total pest management time by 60% within 3 years. Peat moss, the unsustainable amendment. While not directly toxic to soil life, peat moss represents an unsustainable choice with both ecological and soil health drawbacks. Harvested from ancient bog ecosystems that take thousands of years to develop, peat mining releases stored carbon and destroys critical habitat. From a soil perspective, peat is essentially an inert material. It holds water but contains minimal microbial life. It does not contribute to the soil food web development and gradually breaks down, becoming hydrophobic over time. Gardens regularly amended with peat often develop unusual layering that can impede water movement. Coconut coir offers similar water retention benefits while being renewable. Even better are locally produced alternatives like leaf mold, which is partially decomposed leaves, that actually introduces beneficial fungi while improving soil structure. My side-by-side tests have shown that beds amended with leaf mold maintain better moisture levels during drought periods than those with peat moss. Regenerating living soil, the path forward. The good news is that soil has remarkable regenerative capacity. Even gardens that have received soil-damaging inputs for years can rebuild biological activity with the right approach. The key is shifting from a product-centered to a process-centered mindset. Begin by introducing diverse organic matter. Different types of compost, leaf mulch, wood chips, and cover crops provide varied food sources for soil organisms. Regular small additions are more effective than occasional large ones. Minimize soil disturbance by adopting no-dig methods where possible. Each time soil is tilled or deeply turned, fungal networks are damaged and organic matter is oxidized. Simply top dressing with compost and using light surface cultivation preserves soil structure and life. Increase plant diversity in your garden, as each plant species supports different soil organisms. Polycultures of plants rather than monocultures create more resilient soil ecosystems. Include flowering plants throughout your garden to support above-ground beneficial insects that contribute to the soil food web when they complete their life cycles. Most importantly, trust the process. Rebuilding soil health takes time, typically 2 to 3 years before reaching a new equilibrium. During this transition, you may need to provide more support to plants as the natural systems recover. But the reward is a garden that becomes increasingly self-regulating, requiring fewer inputs and less intervention with each passing season. My own journey toward living soil gardening has transformed my relationship with the garden. Where I once fought constant battles against pests, diseases, and nutrient deficiencies, I now spend more time observing and less time intervening. The garden has become both more productive and less demanding. If you've found value in understanding these soil-killing ingredients, please subscribe to Botanical Bliss for more insights into creating truly sustainable garden ecosystems. Share this video with fellow gardeners who might benefit from this knowledge. Together, we can move beyond the chemical dependency cycle toward gardens that improve rather than degrade with time. Your soil is alive, and with the right care, it becomes the most powerful ally in your gardening journey.